for 1a, we're just trying to find out if this actually has an answer. We can't integrate this with our knowledge so far. So what we're just trying to find out is there an answer that's out there? So what you could do is you could say, well, x over 2x to the fifth plus 3x squared plus 1 compares to x over 2x to the fifth. Which one's going to be larger, the one on the left or the one on the right? The left, because when you add more to the denominator, when you add this extra junk in the denominator and x is greater than 0, won't this just make this smaller? Okay. So this simplifies to 1 over 2x to the fourth. And that's going to be greater than x over 2x to the fifth plus 3x squared plus 1. And your question is, how do I know what to use? We'll take the greatest exponents and just get rid of the rest and see what happens. Let's do that with part B. X squared minus 1 over the square root of x to the seventh plus 1. What do you want to compare that to? We'll get rid of the 1 and just leave x squared, get rid of the 1, square root of x to the seventh. Which is going to be larger, the one on the right or the one on the left? With this extra here, it's going to be larger on the left. So this is going to be greater. We'll simplify it down. This is x squared times x to the negative 7 halves. So what's 4 halves minus 7 halves? Negative 3 halves. So x to the negative 3 halves is going to be greater than x squared minus 1. Square root of x to the seventh plus 1. So this is what you do for part 1, step 1. You want to figure out the inequality. And once you get that, now you're ready for step 2. For step 2, all you have to do is to integrate 1 half x to the negative 4 dx going from 1 to infinity. So this will help you for the quiz today. Let's do this improper integral. 1 half x to the negative 3 over negative 3 going from 1 to infinity. And this is rewritten as 1 over 6x cubed going from 1 to infinity, which is the limit as capital N goes to infinity of negative 1 over 6 n cubed. This is how we handle the infinity properly. And then it's going to be minus a negative 1 over 6 times 1 cubed. Well, what does this go to? This goes to 0. And what will this be? 1/6. Therefore, since 1 over 2x to the fourth is always greater than x over 2x to the fifth plus 3x squared plus 1, on the interval, by the way, 1 to infinity, and integral from 1 to infinity of 1 over 2x to the fourth dx converges, meaning we get an answer. We got 1/6. Then what? Integral from 1 over infinity, x over 2x to the fifth plus 3x squared plus 1 dx converges, gives you an answer by what? Comparison test. And so this would be what I would call step 3, writing the since statement. Let's break it down one more time. First part, you just need to block this off so it's a simple expression, power of x, or simpler. And then if you can say that that's always greater on that interval, 1 to infinity, then you integrate the one that's simple, and if the bigger one is a number, then the smaller one will have to be what? If this is a number like 1/6, the area, and it's greater than this, greater than 0, this has to be an answer. That's what comparison test does. So we find that answer, 1/6. Then we say, since the inequality, this is always greater, and the larger one is 1/6, converges, then the smaller one converges too. You finish part B. So it looks something like this. 2 to infinity, x to the negative 3/2, which will be x to the negative 1/2 times negative 2/3, going from 2 to infinity. Oh, yeah, negative 2 because of the, yep. So this is going to be negative 2. Thank you. So then this is going to be the limit as n goes to infinity of negative 2 over the square root of n minus a negative 2 over the square root of 2. And what will this simplify to? This goes to what? 0. And this will just be 2 over the square root of 2. Therefore, since x to the negative 3/2 is greater than that whole big mess that we had, and integral from 2 to infinity of x to the negative 3/2 converges, then integral from 2 to infinity of whatever that was, x squared minus 1 over the, what was that, the square root of x to the 7th plus 1, converges by comparison test.